Okay, for homework problem 2, I'm going to go ahead and just follow that same strategy that I used last time, where I'm going to label these vectors and break them into their component parts. So in this case, again, I'm going to start at the origin and see where I go. In this case, I'm going down first, and so I'm going to call that vector A. And we can see here that vector A has a magnitude of 125 meters, and then, oh, we've got this similar triangle situation going on rather than an angle measurement, but that's all right, that'll be fine. And then, oh, we've got 3 here. We'll call this one B, coming straight up this way. We don't have to worry about a triangle measurement there because we can see that's only going to have one component. That's just going to have a vertical component. And then let's put C coming down here. Call that vector C with a magnitude of 130 meters. So again, we're looking for this resultant vector here. I'll just leave that black at some angle beta from the horizontal. We want to figure those things out. So let's start off with vector A again, and I'm going to break that into its vertical and horizontal components just so I can kind of see what I'm dealing with here. And again, up and to the right are going to be positive. So in this case, AV is going to be negative. It's coming down here to wind up here. I have to go down and I have to go to the left. So AH is also going to be negative. All right, for B, well, I just have a BV. In fact, I can just call B BV because there is no BH. I can write that here just to remember it. And then, look, that's going to be positive. That's just going up. And then for vector C, I've got some amount of horizontal coming over here, C sub H. And that's going to end somewhere around there. And then I have to get down to get to my final point here. I'll have some C sub V. So looking at our positives or negatives, C sub H is going in the positive direction and C sub V is going into the negative direction. So that's what it looks like to start off with. If I want to, I can sketch my resultant stuff in here. So I got a little different color blue, but we can try it. My resultant comes up at this angle here. That's that angle beta. So it's going to be kind of tiny. It's going to have some RH and some RV. And it looks like those are both going to be positive. So we can check ourselves and make sure our math is right to see if we get positive components for that resultant. All right, let's start with this A vector. And we'll think about what AH is. Now, because this is a similar triangle situation, I'm going to use that to solve it. But as we talked about in class, you could instead figure out what the angle is and go back and use sine and cosine. You could use a different strategy. But I'm going to go ahead and draw these triangles here. So I'm told that what I'm going to get is going to be similar to this. It's a 3, 4, 5. And then what I have is what I know. I'm looking for these two components, but I know this is 125 meters. So I'm looking for my AV and my AH. And so what I want to figure out is 5 times what, actually you can still see that, is going to get me to that 125. So you can put that in your calculator or maybe just know that, that's going to be 25, right? 5 quarters makes $1.25. Good on that. All right, so that's going to be 25 is going to be my scale factor or multiplication factor, depending on how you like to think about it. And so now in order to find my AH, I'll just take that 125, I'm sorry, I'll take that, 3, H4, and multiply it by 25, my scale factor. So my AH is going to be 100 meters, and my AV is going to be the vertical side there, 3 times the scale factor, 25, so that's going to be 75 meters. And you can check yourself after you do that, does that make sense? Okay, yeah, my legs have to be smaller than my hypotenuse, so if I'm getting something bigger than that, need to think about it again. Now I also want to think about their signs. Remember I said AV is going down, AH is going to the left, so those are both negative. So make sure you get those on there too before you get too far. All right, B, kind of funny, right? It just has that B vertical component, so pretty easy. BH is going to be equal to 0, as we said, and B vertical is just going to be that whole magnitude there. That's just that 150 meters. And we said it is positive because it's going up. So that was an easy one. But let's go on to C. That's going to be similar to my A here, where I'm going to draw out my triangles. So for this one, I have a 12, 13, and 5. And so I'm going to draw what that would be like here. I only know that one side is 130. Okay, that's a pretty easy scale factor there, because 13 times what gives me 130. That's pretty easy to figure is 10. All right, so now I have to go back to my originals here. Let's do the CH first. So it's going to be 12 times 10, and that's going to be 120, and let's just put our units in there, meters. And then my CV is going to be 5 times 10. Whoop. So that is 50 meters. Now let's check our signs here. Back to the drawing. H is positive and V is negative. So we'll put the positive sign on the H and the negative sign on the V. All right, I've got all my components together. So now, just like last time, I just have to add up the horizontal and add up the vertical, making sure I put those signs on there as well. So let's see if I can fit it on this page. So my RH is going to be AH plus BH plus CH. And in this case, my AH is negative 100 meters. My BH is a 0, that's an easy one, and my CH was positive 120 meters. Don't even need a calculator for this one, that's just going to be 20 meters, and if you want to put the positive on it, that's fine too. And yep, that checks out. We said that was going to be a positive, it was going to be kind of small there, so that seems about right. And then my resultant vector in my vertical, AV plus BV plus CV. AV is the negative 75 meters. BV is the positive 150 meters. And CV the negative 50 meters. So when I resolve all of that, I wind up with a positive 25 meters. And that seems about right too. About almost the same size there, those two components. I mean, you could draw this to scale and really figure it out, but you get a little bit of an idea there. All right, so let's go ahead and find that resultant. This time I'm going to take these two, same thing, my RH squared plus my RV squared, RH squared plus RV squared. So in this case it's 20 meters squared plus 25 meters squared. Take the square root of that sum of the squares and I wind up with 32 meters. And then, I'm going to fit this on here. My beta is going to be the inverse tangent of RV over RH. And let's just make sure that looks right here. So beta, whoop, come on down. Beta, remember, is my angle from the horizontal. So I remember tangent is opposite over adjacent. So yeah, my opposite is the vertical and my adjacent is the horizontal. So that is going to give me this angle in here that I'm looking for. And when we put that in, we get the inverse tangent of 25 meters over 20 meters, which is going to be 51 degrees. All right, fit it on the page.